Okay, Algebra 2. We are starting Chapter 10. We're going to dabble in Chapter 10, see as far as we can get in Chapter 10 before the end of the school year, but I do want to make sure that we get a little bit of this introduced. This is the stuff on statistics, like your intro to statistics. So when you actually take, like, if you're a senior and you actually take my statistics class, we deal with a lot more in depth. But this is just kind of scratching the surface on what statistics encompasses and that type of thing. So 3 main things that we're going to talk about in section 10.1. Okay, first one is we got to talk about what the difference between a sample versus a population is. Okay, sample versus population. We'll dive into that just a little bit. Then we're going to talk about types of samples that you can do, which is these 5, and we'll go through each one of those. And then the last thing we do is, like, after we've decided these are the people that we're going to sample, that type of thing, we design whether we're going to give them a survey, whether we're going to do an experiment or an observational study with our sample. Okay, so which one of those 3 in our types of studies? So, like, progression of things, like who is our population, who are we going to sample? That's step number 1. Step number 2, how do we go about choosing our sample of people that we're going to survey or whatever? And then what are we going to do once we get that sample? Are we going to survey them, or are we going to put them through an experiment where we give them like a placebo and a treatment? Are we going to just observe behavior? Okay, and so we'll talk about each one of those 3. All right, so few things. Samples versus population. Population is your overall group. Your population, though, does not have to be every single person everywhere across the whole world. Maybe your population is everybody in the state of Nebraska, and your sample is just the people in Blue Hill. Now, you could then instead have your population be everybody in Blue Hill, and your sample be the students in Blue Hill. Okay, so your population and your sample can change depending on who overall you're interested in, like, finding things out about. Okay, so maybe I want to know how many people in Blue Hill have blue eyes, and I'm going to survey all of the students to figure out, okay, this percent of students have blue eyes, so probably about that many percent of everybody in Blue Hill would have blue eyes. That type of thing, okay? So your population and your sample can switch just a little bit, okay? When we start talking about data, anything that has to do with statistics, so you've heard the word statistics before when it's referred to like data, like this is a stat, okay? Statistics have to do with your sample. Sample statistics, okay? So like any data or any mean, median, mode, range, those are all statistics if it relates to your sample. The same thing happens, though, if you're talking about a parameter. A parameter has to do with the population. Parameter. And that's kind of easy to remember because S starts with S and P starts with P. Like population, parameter, statistics, sample. Okay, so like maybe I'm talking about the mean of a population, that would be a population parameter. If we're talking about mean of a sample, that would be a statistic. Okay, so same thing, but one of them is a statistic versus a parameter, depending on whether it's sample or population. That's how that breaks down. Okay, all right. Let's say we've decided that we're going to survey everybody in Blue Hill, and then we need to pick the students, right? Okay, so how am I going to go about picking those students? Am I just going to go and do a simple random sample and do like a random number generator? So assign every student alphabetical order, a number from 1 to 120, however many there are in high school, and then just randomly select. We can do a random number generator. So I'm going to say number generator. We can do number out of a hat. That is a way of choosing them randomly. So in a simple random sample, each member has an equal chance of being selected. A simple random sample is the best method to do when choosing a sample. Oh, shoot. Best method to do when you're choosing the sample. Let me see what's going on here. There we go. Best method to choose when you're choosing your sample is just to do a simple random sample. It might not be the fastest method because then you'd have to go and find each one of those people, but it's certainly like the best to have it as randomized as possible, okay? We could do something called a systematic sample, and what this means is that, let's see, systematic versus stratified. Here is the difference between systematic. Well, let's just go systematic. Systematic would be like, let's say I list all the students in order, or like go out of the phone book or something like that, and let's say I choose every 5th person. Or maybe I do every 10th person. Like I start going in order and I go by, this one and this one and this one and this one. That's systematic. I have a system going, okay? Best use of systematic sampling is when you have let's say you have an assembly line in a factory, and let's say we're producing light bulbs, okay? I want to make sure that those light bulbs are all going to work, but I don't want to test every single one of them. I don't want to plug every single one in and make sure it's going to light up. So I'm going to pick every 10th light bulb, plug it in, and if one of them doesn't work, I might investigate further and look at all of the light bulbs that are next to that light bulb that didn't work, just to make sure that that was an isolated incident and not a bigger problem. But that's systematic. There's a system to it, and system is like every 5th one, or every 10th one, or every 3rd one, or every other one. Like maybe it's skipping one person and going through and creating a sample, okay? This next one is a self-selected, and right next to self-selected, I want you to put the word volunteer. Okay, you guys at some point have probably been a part of a volunteer sample before, okay? You probably were just recently if you voted for prom, right? We went and asked you, would you please vote for prom? But, there were several people that said, no, I would not like to. And that's fine. You voluntarily could decline not to vote for prom candidate, whatever, right? So self-selected sample, members volunteer to be included in the sample. So, you can decide whether or not you want to be a part of that. You might have been on social media asked to fill out this survey or whatever. That's a volunteer sample. Now, I'm going to put a star next to volunteer, and there is a problem with volunteer, and it has to do with the bias of volunteer sampling, okay? That looks like an A. Volunteer. Okay, so the bias that occurs is that people who are very strongly opinionated a lot of times will be the ones who will volunteer first. So my example is going back to not the last presidential election, but the one the year before, or the time before, where it was Hillary Clinton running against Donald Trump, right? And the whole time everybody said, oh, Hillary Clinton's going to win, Hillary Clinton's going to win, and then everybody was super surprised when Donald Trump came out and, won the election. Well, what was happening is a lot of times they will collect data before the actual official election begins. So they'll call you on the phone. I had several phone calls, like, who are you going to vote for? Who are you going to vote for? And I hang up the phone right away, and I just click because I don't have time. I don't have time to sit on the phone and explain to them why I'm voting for this candidate, whatever. I don't have time for that. But who does have time? The people who are either strongly for Hillary Clinton and against Trump, or strongly for Trump and against Clinton. And what was happening is the volunteer people, the one who were strongly opinionated, were more strongly opinionated for Hillary Clinton and against Donald Trump. But the people who were the I'm not going to answer this, the ones that were just kind of like in the middle, like, oh, I'm not strongly opinionated, but, this is who I'm going to vote for. Those people all came out on day of, and they voted for Donald Trump. And then it looked, like the results were just completely blown out of the water. So there is a bias, because people who are going to volunteer, these are going to be the strongly opinionated people. Strongly opinion. I'm just going to say strong opinion. How about that? Strong opinion are going to be the ones to vote. Opinions. I didn't spell it right. Go back. Opinions. Okay, so you're going to get those strongly opinionated, either really, really strong yeses and really, really strong nos. If you think of it as like on a scale from 1 to 10, how do you feel about this? You're going to get all of these people and you're going to get all of these people, but you're not going to get very many people in the middle. and you need to have data from those people. Okay, so that's the problem with a self-selected or a volunteer sample. Okay, a convenient sample also has some flaws, but this would be an example of, like, let's say I need to know the height and weight of high school students, right? Like, I need to know that information, and what I could do is, rather than surveying them myself, and rather than collecting that data myself and having them come and stand on a scale and measure them on the wall, how tall they are, I could just go to their physical forms that are in the office. I'd have to have permission, HIPAA, whatever, all that stuff. But I could go to the permission forms, or their physical forms, and I could get that information just from their physical forms. But problem is, maybe not in Blue Hill, but like if you would go to a university, who are going to be the people who have physical forms? The athletes. Athletes might be more fit than the average person, like less weight, or they might be more weight, or they might, if you're dealing with a football team, or they might be taller if you're dealing with a basketball team. So convenience sample would be like, I just want to do an example, or I'll just put a star here. This would be like physical forms in the office. Forms. And then I'm going to have you put bias next to that. Bias, because, there could end up being issues with choosing just those people and not the non-athletes that don't have physical forms in the office. We need to get information from them as well. Then the last one is stratified. And stratified, let's do like a little picture here. So let's say I have 3 towns, and they are Blue Hill, and they are, I know Silver Lake's not a town, but schools. Let's say we have Blue Hill School, Silver Lake School, and Red Cloud School. Those are in what's called strata, so they are like naturally already grouped, and we're going to survey like 5 students from each town. Okay, so we get a little selection of each, grouping. If we're, it depends on what it is we're asking. So these are different ways of sampling or creating a sample, and the way that you use is going to depend on what you're asking. So a simple random sample is going to work for just about every scenario, but like if I'm wanting to know, let's say, the roads in Webster County, what people think of the roads in Webster County, I'm not going to survey just the people from Blue Hill. I might want to do a stratified where I get, okay, five opinions from Blue Hill, 5 opinions from Silver Lake, 5 opinions from Red Cloud, so I get a little bit of each one, okay? So just depending on what you're asking, or the information that you're trying to gather, is going to determine which sample you use. Okay, let's do some examples. Here we go. The administration of Jefferson High School developed a free app to help their students with studying and organization. At the end of the school year, the students were asked to complete an online questionnaire about their satisfaction with the app. Classify the sample. So we need to figure out which one of these it is, okay? Now, my population was all, they said identify the population, is the entire student body of Jefferson High School, okay? The sample is just the students who responded, okay? Now, did you get to choose whether you responded? Yes. So that is like a volunteer or a self-selected sample. So the sample is self-selected. And that's what they mean by classify the sample. Which type of sample is it? Which one of these 5 is it? It's a self-selected sample. Okay. All right, let's do the check real quick. A club member would like to ask the other members in her state's council about new requirements for the first-year members. Classify each sampling method. So she chooses every 5th member on the council roster and just asks them this questionnaire, okay? Every 5th person, that would be systematic. We have a system going. So systematic, okay? She asks every other club member in her 25-member club, every other member. That would be like every 2nd member, okay? That also is going to be systematic, okay? It's every other club member, so that's like every 2nd person. You skip one, you go to the next one. Skip one, go to the next one, okay? She splits the council into 4 age groups and randomly asks 20 people from each age group. That sounds a lot like this Blue Hill, Silver Lake, Red Cloud. We have age groups now instead of towns. Age groups, and we're choosing 20 from each. So that is going to be that stratified. That was kind of confusing, part B. I wonder if they were trying to get. She asks every other club member in her 25-member club. Every other, yeah, that's still systematic. I don't know. Anyway, okay, so there's that. Example 2. The Traffic Commission took a random sample of travelers using Route 15 and determined the average daily commute on this road during rush hour. After viewing the results, the commission proposed to expand the road from 2 lanes to 4 lanes. So evidently this is a widely trafficked road. We need to make 4 lanes instead of 2 to get everybody down it because there's just lots of built up traffic, okay? Identify bias and potential interest in the sample, okay? Now, with going from 2 lanes to 4 lanes, we end up with a lot of cost involved, okay? And if you're only asking the people who are going down that road, of course they're going to say, yeah, let's make it a 4-lane road because that's the road that I travel, versus somebody else that's on another highway that has the same amount of congestion in their travel, right? They might say, no, come work on my road instead, right? So there's a bias there because we're only asking, after viewing the results, the commission proposed expanding the road from 2 to 4 lanes. We're only looking at that information. We're not taking other things into consideration. So let's see what they say. The bias is in the blank may lead to a sample average that does not reflect the true average commute of the... I see what they're saying. So yeah, another thing, we're not taking every route into consideration. We're only looking at that one route, and we're looking at average commute in that one route, and maybe the average commute might be more if we look at all of the routes going from one place to the other, okay? So yeah, we're only looking at one route. Let's see. Identify the purpose of the sample. The purpose is to evaluate the length of the commute in order to determine whether the road expansion is necessary. While the sample is random, a sample size of 10 is too small. Okay, so that's another thing that we could take into consideration. We need to probably survey more than that. So that's another problem. There's a lot of different things that we could say are bias, right? Like there's a problem here and there's a problem here. There's not just one. A lot of times there's a bunch of flaws in the way that we survey things. The bias is in the blank may lead to a sample average that does not reflect the true average commute of the population, is in the sample. The sample may lead to, I'm going to say the sample average, may lead to a sample average that is the bias in the... Okay, maybe we should do average commute. Because they did say sample average. So let's say the bias is in the average commute. May lead to a sample average that does not reflect the true average commute of the population. The bias could serve the interest of contractors who hope to win business of expanding the road, right? So again, it's just the people who are driving down that road. Of course, they're going to say, yeah, make my commute 4 lanes instead of 2 because that's going to, prefer them. Lots of different ways that we can look about this. Not a very good setup example, okay, or a very good setup sample. There's lots of different things that are going bad with that, okay? All right, next thing. A restaurant owner, and we're identifying bias here. A restaurant owner wants to determine which kind of meal she should add to her menu, a vegetarian option or a more traditional meat-based. Okay, here is the survey that she sends out. She sends out and it says, do you prefer a plain salad or a delicious steak? How could that be misleading or how could that be biased? I'm going to guess if you ask that, more people are going to choose the delicious steak, of course, because the word delicious sounds more appealing than the word plain, right? So we've inserted those adjectives in there, and that was not a good choice of wording. Maybe we just leave out the adjectives and just say, do you prefer a salad or a steak? And not put in the words plain or delicious, okay? So the wording of the question is not very good. The question provides descriptions of each kind of food, and the description for the plain salad, no, delicious steak favors plain salad. Delicious steak favors it over the plain salad. Okay, so wording is important. All right, last thing, types of studies. So we're going to do a survey, an experiment, or an observational study. Survey is asking a question. Okay, so whether it's paper pencil, whether it's calling them on the phone, whether it's you standing at the entrance to a building with a clipboard and asking them something, you're asking questions in a survey. That's pretty straightforward, okay? Now, experiment and observational study are a little bit kind of gray area sometimes, but the important thing about an experiment is that you have two groups. Okay, two groups. You have a control group, which a lot of times is given a placebo, and then you have a treatment group. I'm going to say control versus treatment. Okay, and with an experiment, you are doing something to them. Okay, so I'm making them do this exercise regimen where I'm making them run on a treadmill for 5 minutes and the other group doesn't have to. Or I'm making them take this pill and the other group doesn't have to. So I'm going to say administer treatment. Okay, so control versus you administering a treatment to the other group. Okay, now observational study is just watching, I'm going to say watching behavior. Okay. All right. Now, watching behavior. You have to be very careful. And let me give you an example of when I would want to do an observational study over a survey. And this is going to sound weird, but just go with me on this, okay? All right. Let's say I ask you all, when you go to the bathroom in a public place, do you wash your hands for the correct amount of time that you're supposed to? And when I ask that, I'm probably going to get a lot of lies because you're scared that I'm going to judge you if you don't say, yes, of course I wash my hands the way that I'm supposed to. If you say, like, no, I probably don't wash them the correct amount of time, like I just kind of put water, put soap, run my hands under and call it good, like I'm not washing my hands correctly. I'm going to you're scared that I'm going to oh gosh, you're disgusting. Like you're scared of that judgment, right? So some people might be more apt to say, to lie in that case versus if I actually observe behavior, right? So get your mind out of the gutter. I'm not going to put a camera facing the stall. Okay, I don't want to know what's going on in there. But if I put a camera facing, let's say the sink, and I actually watch people that walk through and see if they're correctly washing their hands, that might give me a better idea or give me more accurate information, right? Okay. Now, I would not probably want to sit in there with a clipboard in the bathroom because if you know that somebody's watching you and you don't even know what it's for, you're probably going to try to do everything correct and follow all the rules, and you're going to wash your hands correctly if you think somebody's sitting there watching you. So we have to kind of be behind the scenes and not let them know that we're observing them sometimes. I mean, making sure that we're following HIPAA and we're not breaking any rules or laws or anything by them knowing that we're watching. But, we want to get accurate data, right? Okay. Another thing that's a gray area between experiment and observational study is this. Let's say I ask, and I pick on females because you guys lie about your weight. Maybe not you freshmen because, you're all thin and good looking and everything. But older women are going to lie about their weight. If you ask me how much I weigh, I'm going to lie by at least 10 pounds and say I'm 10 pounds lighter. That's just the way that I work. A lot of other women as well. Okay. Observational study versus experiment. Here is what, okay, I wouldn't want a survey because if you ask me my weight, I'm going to lie to you. Okay. So what I'm going to do instead is I'm going to, if I wanted to get heights and weights and everything of those people, I'm going to actually have them come up, stand on a scale, and get their accurate weight. That's why they don't ask you in a doctor's office. That's why they actually weigh you, okay? And some people might not be lying. They might just not know exactly what their weight is, right? Like some people just don't know. They haven't weighed themselves in a while, okay? So they do that. Now, a lot of people think that since I'm having them come up and stand on a scale, that is an experiment. Okay, that is actually an observational study. Yes, I am administering something to that, like I'm making them come and stand up on a scale, but I do not have two groups. I'm not feeding them something before they come and step up on the scale. If I was doing that, that would be an experiment. But an observational study, I'm watching the behavior. I am having them come stand on a scale and recording information. Okay, so little bits of confusion between survey, experiment, observational study. Let's go to an example. Here we go. A research team wants to test new football uniform designs and their appeal to young adults. They randomly select 100 young adults to view different uniforms, and the research team observes and records the reactions. Okay? Now, why would they observe and record their reactions instead of just asking them, like, hey, what do you think about this? Okay? Like, if, I don't know, somebody would come to me and say, like, hey, I designed this shirt, what do you think of it? And they put a lot of time and effort into it, and I think it's ugly. I might be like, yeah, that looks cool. I think it's really good, even though I really don't, because I know how much time and effort they put into that. So what we would want to do instead is like show them the design, like look at their facial expressions, because sometimes people can't lie on their face, right? Like observe and record reactions, okay? Rather than just asking them information. So, is this a survey, experiment, or observational study? This is going to be an observational study, and I'm going to abbreviate. Okay, because I want to gather their opinions. The sample is the they randomly select 100 adults. Okay, so the sample is 100 young adults. Okay, involved in the study. The population is new football uniform designs and their appeal to young adults. Okay, so it's just all young adults. We want to know what those 100 think in comparison to everybody's opinion of these new uniforms. Okay, so there's how that works. All right. Oh gosh, we got a lot more going on. Let's stop there because I feel like we've done a lot already and I've talked a lot already. So let's stop there. We might hit on some more of this tomorrow, but what I want you to do is I want you to do 1, 2, 3. Okay, you're just doing which one of these it is. And then when it says explain your reasoning, do explain your reasoning, but you can underline things in the sentence that tells you how you know that, okay? So just underline words that make you know that it's a convenience sample or make you know that it's a systematic sample, whatever, okay? Then let's just have you do 4, 6, 8, 10, and 12, 14. Okay, and then we'll stop there. All right, so do 1, 2, 3 all, and then do 4 through 14 evens. 1 through 3 and 4 through 14 evens. Okay, page 515. Okay, so sorry I was long-winded a little bit, but I get kind of like fired up about statistics. I think it's kind of fun. So do those, and we will talk some more tomorrow.